Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. So, another installation about the body that's thrown at the angle alpha with some initial speed, v0. So let's recap what we did in previous form. We realized that we can superimpose two motions. One is horizontal, and this motion, no acceleration, it's a constant speed. And the speed is v0 cosine alpha in this direction. And another independent motion is vertically. And vertically it's a free fall. Free fall with initial speed up, and this initial speed is v0 sine alpha. So body goes up and body goes this way. This way it's with acceleration g that directed down. This is constant speed. We also realized that when it goes up, the maximum height is determined by this motion. It is exactly the same formula as we saw before when we were starting with v0, but here we have v0 sine alpha. So the height was this, the time to reach this point was this, full time to go up and down was double, and then we realized that during that time the body travels in this direction, this distance, because it is horizontal v0 cosine alpha multiplied by that time double, and then we introduced the formula of double angle, 2 sine alpha multiplied by cosine alpha sine 2 alpha. So this is the formula for the length. And then in the last installation we realized that we can describe this motion as x and y. X is v constant motion with constant speed, and y motion is square formula, square dependence from t. We got parametric formula for trajectory, and then we excluded t, there was no t, and we got that y depend from x as square root, as a polynomial, as polynomial of a second degree. And polynomial of a second degree, graph of it is parabola, so the trajectory is a parabola. And we determined this point, which is 0, which is obvious, and we determined the L, the second root of this parabola. It came to the same solution, and then we found in the middle of this parabola how high it is, and we found this. So this is a recap of this work that we've done in previous 4 clips. Now they're asking us, what if alpha is not given? And they give us only v0, and they say, find me such an alpha that it would be maximum distance. Because indeed, let's take extreme situation when we throw horizontally. We throw horizontally, this distance, this parabola would be like a dot. There would be no distance. We throw at very narrow angle and it comes very, very soon. We throw a little bit more and it comes a little bit. So if we draw this L, how it depends from this angle alpha, if alpha is 0, L is 0. But then it grows a little bit. Now let's go from another end. If we throw it vertically, it will come like that. Again, it would be very close to 0 at 90 degrees. If we throw it vertically, this angle is 90 degrees, it goes up and it goes down. Up and down. This is the whole playlist that we just looked, kinematics in 1 dimension. So no shift in this direction, so this L, this distance becomes 0, and this is what I'm denoting here. So in the end, obviously at some angle, there should be a maximum of this function, because the function goes like this, somewhere there is a maximum. And they ask us to find at which angle there would be a maximum L. So V0 is fixed, and we have this formula, V0 squared sine 2 alpha divided over G, and G is known, V0 squared is known, so all they want us to do is to find where is the maximum, and the maximum when sine 2 alpha becomes maximum. But we know that sine is such a function that can go between -1 and 1. And if we talk about alpha in this area, then it goes between 0 and 1. So for alpha equals 0, sine 2, 0 would be sine 0 would be 0, right? But the maximum value is 1. And the maximum value sine 2 alpha is 1, and it immediately means that 2 alpha equals 90 degrees. And that immediately means if we send 2 to the bottom, divide by 2, both parts, we have alpha equal 45 degrees. And what that means? That means that we have, if we have V0 and our goal is to send this body as far as we could, we should aim at 45 degrees. And then there would be the longest parabola. Parabola would be like that. And this distance L becomes V0 squared over G, right? And sine 2 alpha is gone, it's 1. Multiply by 1, so we can write it, we cannot write it, right? And basically that's it. This would be this parabola at 45 degrees. If we throw a little bit smaller angle, this would be this. If we throw it at bigger angle, it would be this. And as we will grow the angle, the L will go from here to here. And then when we reach 45 and then we continue to increase the angle, it will start to decrease. This would be the maximum, and then it will start becoming smaller and smaller as we grow the angle above 45 degrees. Incidentally, I want to say that you notice how I always put characters. I never put the numbers, I put the numbers in the very, very end. And that's example why it is so important. Imagine that I would have put this angle that they gave 30 degrees, and I put it everywhere. Now there would be some number. There would be like sine of 60 degrees. I will have L equal, and instead of V0 I put 10, and I put 10 squared, and sine 60 degrees, right? Divided over 10, and it would be something, right? Some number. Doesn't matter what. Try to then answer this question at which angle the length would be the maximum. It would be impossible, because there is no dependency from alpha. It's hidden. It's hidden as soon as you put the specific number. When you put the character, you have all dependency in front of your eyes in this formula. So keep it in your formula for as long as you can, and then plug it in the last possible moment. And that's a very important observation, and I hope it's explained to you why I put the numbers in the very, very end. And I think I will be coming back to this problem for the duration of this playlist, but for the time being, I think this is the 5th installment of this V0 and alpha and throne. And important thing here, one thing I forgot, that G is constant. Everywhere where it flies and constant, that means if we look on Earth, Earth has a curvature. But this, we all look in a very small area, 100 meters, 200 meters, 20 kilometers. And during this distance, G is everywhere the same. Everywhere is the same. But when we will be touching orbital motion, it will be completely different because we will be flying very far from this flat situation, right? G is constant when we can approximate a very small area where all the process is going on. The process is like, in our numbers it was meters. Like if you throw something bigger or cannonball or something, it would be a kilometer, 5 kilometers. Still very small to the radius of the Earth. Radius of the Earth is 600, 300 kilometers. So even 1 kilometer is negligibly small, and we can assume that G is the constant thing. But I am running a little bit ahead of myself, so for the time being, this is a parabola, and parabola has the maximum length and certain angle, and this angle is 45 degrees. I hope you enjoyed this problem. If you enjoyed, click like. If you want the next like this, click subscribe and click bell to be notified. Question, problem, we'll be glad to answer. Thank you.